So we are discussing about the RMS power, average power. So see, we are discussing about the RMS, average power and all everything. Okay. Now add section. Suppose you have means you need to find you need to you have a graph like this. Okay. This is T and this particular is your V of T. You need to find the average power, not average power, you need to find the RMS power of this wave form. Okay, it's going like this. So it's T by 2, it's T. Okay, and this particular is your Vm. Okay, so this is your signal. So how you will find the RMS power? So guys, the formula for the RMS power, Vrms, is root under 1 by T 0 to T V square of T
dt.
So guys, for this triangular network, this triangular signal, how you will find the RMS power? So for this you have to know some basics. Guys, you know y is equals to mx plus c equation. This m means slope. Okay, and this particularly if you have a graph like this, so this equations represent y is equals to mx plus c. This is a slope m. So you need first, if you want to find the RMS value of this, you need to find the equations of this. Okay, so from 0 to T by 2, this is your T. Okay, so here that is x, y. Now we are representing in terms of v of t and t. So y of t is your v of t and your x is t. So what is the slope? Slope m is equals to y2 minus y1. This is your Vm. So y2. So this is y2 minus y1. So Vm minus 0 divided by x2 minus x1, that is t2 minus t1. So t by 2 will come. So slope you are getting 2 Vm by t. So you will put the equation v of t is nothing but y is equals to mx plus c. So 2 Vm by t into t plus c, and the c is 0 because it is intercepting at the 0 point. It is intercepting at the 0 point, so it is 0. So you got the equations of v of t. You got the equations of a v of t. Now if you substitute in this equation 1 by t 0 to t v square of t into dt. So root under 1 by t 0 to you know the value up to 0 to t by 2. That v of t is how much? V of t is value, what you got the value of a v of t? 2 Vm t divided by t the whole square. Okay, the whole square. That is your equations. T is also there, into dt. Now this is plus, you have a t by 2 to t v of t whole square into dt. Now you have to find the equations from here to here. Okay, from this point to this point. So what you will get the equations? We will find the equations of this. What you will get? the equations. Y is equals to mx plus c. So y is nothing but v of t only. Your m slope is, this is your t2, this is your v2 minus means y2 minus y1. So y2 is 0 minus y1 is vm by t minus t by 2 into t plus c. Okay, so v of t you are getting minus vm t divided by t by 2. So you are getting the same equations, means like, but minus sign is coming. So if you will square this, so what the value you will get? 4 vm square into t square by, yeah, see, so this is t by 2 no, this was t by 2, t minus t by 2. So here t will be there only. So you will get 4 vm square t square by t square if you will square this. So you will get the same result, means root under, if you will square this 1 by t 0 to t by 2, you will get the same result, vm square t square 4 upon t square. The same thing is coming. That's why we are just multiplying it by 2, because the same result is coming. Now you got the equations 8 by t cube 0 to t by 2 into vm square into t square into dt. Solve this integrations, what you will get? You will get root under 8 by t cube vm square, integration of a t square is t cube by 3 0 to t by 2. Put the value and get the results. 8 vm square divided by t cube into t cube by 8 into 1 by 3. This will get cancelled out, this will get cancelled out, and you will get the result as vm by root 3. So yesterday I told you, you will get the RMS value of any trigonometric function as vm by root 3. So by this way we are getting vm by root 3. Okay, by solving these equations. Otherwise means if you are not able to understand these things, it's you don't have to worry, because these things is going to be repeat in a signal system in a very from a basic points, means you will understand how the signal is plotted. So for now you just have to remember that in any trigonometric function you are getting the VRMS value is vm by root 3. Okay, so what I told you yesterday means if you have a signal like this, the RMS value VRMS will be vm by root 2. If you have the signal like this, your VRMS will again it will be vm by root 2, and the average value will be here 0. And what is the average value here? V average was coming as a 2 vm by pi. Okay, and if you have the signal like this triangle, like this also, or like this also, and it's a sawtooth network, like you are getting a sawtooth network like this, you will get the VRMS is vm by root 3. For this also you will get VRMS is equals to vm by root 3. And for finding the average you don't have to do anything, you just have to find the area and divide with the time period. So if this is your height and if this is your time period, so what is the area of a triangle? Area of a triangle is base into height. So base is how much? Base is t, and height in this triangle will be, this is your vm. So half into base into height. So what you will get, and overall means for average you have to divide by overall time period. So you will get Vm by 2 only. Okay, so average value of in a triangle you will get Vm by 2. Okay, and for a square wave, and for particularly for a square wave, what will the RMS value? RMS value will same. It will be same. If you are having the square value like this area is same. Okay, this is Vm, this is minus Vm. So Vrms will be Vm only, and V average here will be 0, because this positive, this negative will give you 0. Okay, if you understood this thing, now I will give you one. Now guys, you need to find the RMS value of this kind of a signal. Suppose you have a signal like this is T, and time period is T. This is your V of T, and this is your Vm. So what will be the RMS value of this signal? Okay, what will the RMS value of the signal? Prasanna, what will the RMS value of this signal? See, Vrms is equals to root under, means your signal is repeating from particularly from this time period. This is T by 2. So you know the RMS value of this signal, means sinusoidal signal. This is a sinusoidal wave. So you need to put Vm by root 2 the whole square, and to up to what period it's coming? Up to T by 2 period is coming, plus the value is 0. This value is 0 into up to what? 0 the whole square. And up to what value it's coming? Up to T by 2 value it's coming. And you have to divide overall by time period. You will get the RMS value for this signal. Vrms is equals to Vm square by 2 into T by 2 into 1 by T. So what you are getting the RMS value? Vm by 2. Understood? Means the formula for any signal which will be a mix of a different kind of a signal, you need to solve like this: Vrms 1 the whole square up to what time it is coming, T1, plus Vrms 2 the whole square up to what time it is coming, T2, and you have to divide like this. It will go, and you have to divide overall by time period. You will get the net Vrms. Okay, like if I'll give you one question, you have a signal like this is your time period, this is your V of T. If you have a signal like this, okay, and from this it's going, and from here you are getting something like this. This is square wave is coming. So, and from this is your total T, and from this it's again repeating. This signal is again repeating like this. So for this kind of a signal, how you will solve this? Okay, so this will be
RMS value we have to square and add.
Yeah, Vrms 1, this will be Vrms 2, and this will be your Vrms 3. But this is your time period, and this is, here it is given T by 3, here it is given T by 3, here it is given T by 3, means up to 0 to T by 3, 0 to T by 3, T by 3, T by 3, matlab means up to what time it is coming. So your overall Vrms will be root under, what is the Vrms of a triangle? That is Vm. What is the Vrms of the triangle? Vrms 1 whole square into T1 plus Vrms T2 whole square into T2. Yesterday I missed this T1 point. So, and VRMS 3 whole square into T3 divided by overall time period. Overall time period. So, what will be the answer? VRMS is equals to root under VRMS 1 is Vm by root 3 the whole square. Up to what time period it's coming? T by 3. Plus the signal VRMS 2 is Vm by root 2 the whole square. Up to what time period it's coming? T by 3. And this is a square signal, so same Vm only. Vm square into T by 3. Okay. So T by 3. T by 3. And it will be divided by 1 by T. So what value you will get? Vm will come outside, T will T and will get cancel out. You are getting 1 by 3 into 1 by 3 plus 1 by 6 plus 1 by 3. Solve it and get the result. Vm root under, how much you are getting? Solve this and tell me the result. 1 by 3 plus 1 by 9, that is 3 by 9. So how much you will get? 1 by 9 plus 1 by 6 plus 1 by 3. So Vm root under 18 2 3 3 3 3 are 9 18 3 6 will come. Vm root under 11 by 18. This is coming. Prasanna, is this coming?
Yeah.
So this will be the VRMS of this particular signal. Okay, you got it? How to solve this kind of a signal? Understood? Okay, then it's fine. If you understood, then it's good. Okay. If you guys understood, then it's fine. Okay, so your AC circuit is done. We had completed our AC network. Suppose, yeah, there is a 2-3 things I will just tell you, then we'll move to the theorem chapter. Before the theorem, we'll discuss the questions. Okay, suppose if you have a signal like this, means if you have a signal V of t, that is V0 plus V1 sine omega t plus theta 1 plus V3 sine omega t plus theta 3. Okay, how you can represent it is in the phasor. How you can represent this is in the phasor. V0, this is the DC value, and this V1 at an angle theta 1,
At angle of
V3 at an angle theta
V3 at an angle of theta 3.
So this is your RMS value, I am assuming. Okay, this particular is your RMS value. So what will be the RMS value of this circuit? VRMS. It will be root under V naught square plus V1 square plus V3 square. So overall RMS will be this. Here you have to, yeah, that is correct. You have to think like this. Okay. So guys, what will be the result then? Root under V naught square if V1 is equals to V3. So what will be the overall RMS? V naught square plus, what is the RMS value of this? V1 by root 2 whole square plus V3 by root 2 whole square, and here it is given V1 is equals to V3. Then V naught square plus V1 square by 2 plus V3 square by 2. So what the value you will get? V naught square plus V1 square. Understood? Guys, understood? See, RMS value, if you convert this in the RMS form, this value will become what? V1 by root 2. The RMS value of this will be V3 by root 2, and the DC value of RMS will remain that only. So you got the RMS value of this, you got the RMS value of this, you got the RMS value of this. So overall RMS is nothing but RMS. Wait, just wait. Light gone. Just wait, just wait. Guys, am I audible? My voice is coming.
Yeah, now it's come.
Okay.
Before it was not.
Oh, actually,
we can't hear your voice.
light is gone, so that's why. So see,
Yeah,
what
okay.
I am telling to you, you need to find the RMS value. So for RMS value, the DC value, DC, you have a particular V naught means what? V naught means you have a particular DC signal like this. The RMS value of this signal will remain that only. You have the sinusoidal wave. Sinusoidal wave RMS will be V1 by root 2, and you have the RMS value of this also, V3 by root 2. Overall RMS will be square of each. So that's why V1 is V naught square plus V1 by root 2 square plus V3 by root 2 square. Okay, you need to find like this. Prasanna, it's clear?
Yeah.
If you are getting the combinations of a trigonometric function, then you have to find it like this. Okay. Okay. So see, you have one circuit like this. Suppose you have a circuit like this. One diode is connected. In particular, one resistor is there, and one diode is connected like this. This is 10 kilo ohm. This particular is 10 kilo ohm. This is your D2. This is your D1. And this particular is your 4 sine omega t. So guys, in the below given electrical network, both D1 and D2 are D1 and D2, and the ammeter, there is one ammeter, okay, where ideal, find the reading of the ammeter. You need to find the reading of ammeter. Ideal means D1, D2 and ammeter is ideal, means there will be a no loss. It just give you the value. Ideal case means there will be a no potential loss. Okay, now guys, tell me one thing. When your D1 will conduct, you have a curve like that.
Forward bias.
Yeah, D1 will be in a forward bias or reverse bias. It's like
In forward bias, there
no,
will
no,
be
no,
what?
no, no, no. So see, if it is positive, these the current will come in this. If it is negative, if positive and negative is there, that means the current is going from this.
When the positive terminal is connected to the anode of the diode, then the
Okay,
current flow will
so
be there.
that's what I'm telling. See,
Okay.
if it is you have a curve like this, okay, you have a graph like this. So first it's becoming, this is your positive, and means the cycle is changing. Okay, so if it is positive, then the current will move from these directions. Okay, this is this, if this will not conduct, this D1 will not conduct, but because it is in a reverse bias, and this is positive, this is
D1, D2 will be
so
conducted.
D2 will conduct. Okay, so D2 will conduct. So what will the curve you will get? What will be the output voltage you will get? What will be the output voltage you will get? It will conduct. If it will conduct, then what you will the output voltage? The same thing you will get, na? Same. It's following. It's a parallel combinations, right? Positive, negative, positive, negative. It is conducting. So whatever the voltage is here, it will generate in this particular terminal. The same thing you are getting up to positive. But when it is negative, this will off. This particular will off, and this will start conducting. For a negative half cycle means it's following this. So same voltage you will get means, because it is in a parallel, so this curve will come, this particular curve will come, right? So you are getting the same signal. Okay, same signal you are getting. Now you need to find, means suppose you need to draw a separately means like for this branch the voltage will be, it is following the positive half cycle, but the negative half cycle is off. Again following the positive half cycle, but the negative half cycle is off. This is for D2. And if you'll go for D1, so in a positive, in a forward by in a positive half cycle, it is off. It's following the negative half cycle, so the voltage will be like this, okay. So this particular graph is representing what? It's representing your half wave, na? Half wave is coming. So we seen the average value of this. Yesterday we calculated, that was Vm by pi. So whatever the average voltage will be, how much average voltage will come? 4 by pi. You got the 4 by pi value here. And what will be the current? 4 by pi divided by 10 kilo ohm. So that is your 0.4 by pi milliampere current, right? Guys, right?
Yes.
So you are getting 0.4 milliampere current. Okay, and this is about the first. And if you will see from this, you have the signal like this. This is off, this is off, this is off. So here what voltage you will get? Minus 4 by pi Vm by pi. So this is negative, you will get the same minus Vm by pi. What current you will get? Minus Vm by pi divided by 10. So Vm value is 4 only. So minus 0.4 by pi milliampere current. So you are taking in this mode. Okay, so it's coming, means negative it's coming here, your positive it's coming here, and your negative is coming here, and you are getting the voltage in a negative way, okay. So in a positive half cycle, you need to, I am asking about your ammeter current. So ammeter current will be, because understand these things, it's a very conceptual, like you have the figure like this, understand very carefully. You have ammeter, you have diode, this is your diode connections, and this particular, it's 10 kilo ohm resistor, this particular is a 10 kilo ohm resistor, and what I am telling, this is your 4 sine omega t. 4 sine omega t means curve is like this, positive negative positive negative. So this is positive cycle, this is negative cycle. So when the voltage is positive, so which will conduct? This part will conduct,
Diode 2.
D2 will conduct, and this is your D1. So if diode is conducting, so what the equations, what the signal you are getting, what the graph you are getting, like this,
Positive.
like this. What is the average value of this particular graph we had derived yesterday? It was Vm by pi.
Vm by pi.
So you know the Vm by pi average
Vm is given
voltage,
as
positive
4.
negative Vm by pi. So you know the voltage, you got the voltage across this, and if you will divide it by V by R, it will give you Im, average current. So what you will get? 4 by pi into
4 by
10
10.
kilo ohm.
Pi
So
into 10.
0.4 by pi milliampere, 0.4 by 5 milliampere current is flowing, means ammeter will, so what current? 0.4 by pi milliampere current, okay. Now if it is for the positive half cycle, and if it will be in the negative half cycle, what will happen? This will conduct, this particular will conduct, okay, means your D1 will conduct and D2 will be off. So this is conducting, means it's becoming a short, and it is ammeter, and it's getting open circuit because it is not conducting. So in a negative half cycle, you are not getting any current, so that's why we didn't took any current in a negative half cycle, in particularly in this branch, and you are getting the current in this. First it was positive negative, so this current was moving like this, but now it is becoming negative positive, the current will move from this, in this particular graph. I hope you guys understood this concept.
Yes.
Understood?
Yeah.
Okay, now you have one particular question, like you have a resistor, you have a inductor, and you have 4 volt, and you have, and this one ammeter is connected, this is your ammeter, ideal ammeter, means there is a no loss, and it is given sine t volt. This particular is your sine t volt, sine t volt. This is your 4 volt, positive negative, This value is 1 ohm and this value is 1 Henry. So what I am asking what will be the ammeter current. This is ideal, means there is a no loss is there. So what will be the ideal current of ammeter? Ammeter will show how much current? Guys, ammeter will show how much current? Ammeter will show how much current, means you have 1 ampere, 1 ohm resistor, 1 Henry inductor, positive negative 4 volt DC volt is there, and your sin t, you have the two voltage, means one is DC voltage and one is sinusoidal voltage. Then what the ammeter reading will be?
4 ampere.
4 ampere? No, it won't be a 4 ampere. See, for finding this kind of a thing, now we divide the circuit in two parts. Okay, first this is your positive negative and you short circuited this is 1 Henry, 1 ohm, and this is 1 Henry. If it is a DC signal, 4 volt, if it is a DC signal, there is a no omega. So omega L is what? If you are consuming the DC signal and you are putting the omega value is 0, it becoming a short circuit. So by using this, you are getting your I1 of t is 4 ampere. You got the value of 1. Now what you will do? You will get 1 and this, and now you will short circuit your 4 volt. You have the sinusoidal sin t. Here omega value is given as a 1 because sin omega t. So this is your, it will become your J. So now what current you are getting? I is equals to sin t by 1 plus J. So if you will solve this, what value you will get? In the form of angle, what you will get? 1 plus J is sin t divided by 1 plus J. If you write in the form of mod value, means it will, root 2 will come at an angle 45 degree. So I will be 1 upon root 2 sin t minus 45. So what overall current you are getting, this is your I2. So I will be I1 of t plus I2 of t. So I will be 4 ampere plus 1 by root 2 sin t minus 45 degree. Sin t minus 45 degree. Got this? Prasanna, understood how we solve this, or still having any doubt? Vaishnavi, understood? Priyanka, understood?
Yeah, yes, sir.
So what we did, we are using a superposition theorem. Means we are short circuiting this parameter. We are solving this. We got the I1 current, that is 4 ampere. Now we are doing for the AC signal, that is sine t, and this will give you sine t, means omega value is 1. So you are putting here as omega is equals to 1. So you are getting sine t divided by 1 plus j. 1 plus j, the meaning of a 1 plus j is what? 1 plus j, if you solve in the polar form, what you will get? Root 2 at an angle 45 degree. Right. 1 plus j meaning was root under 1 square plus 1 square at an angle tan inverse 1 by 1. It will give you root 2 at an angle 45 degree. So you are getting this 1 upon root 2, and this 45 will go up, then it's become minus 45. And now you have to add this signal. So overall current, how much you are getting? I is equals to 4 plus 1 by root 2 at an angle sine t minus 45. Okay, so I of t, overall I of t is how much you are getting? 4 plus 1 by root 2 sine t minus 45 degree. So this current you are getting. Now if anyone asks you about the two things, what is the average current in this circuit? So average current will be average of a trigonometric function will be 0, because it's getting like this. So positive negative means if you will draw this signal, this is minus 45 degree. So your sine is minus 45. Minus 45 means a delay of a 45 degree. So delay of a 45 degree means suppose here 45 degrees. So it's starting from here. Okay, starting from here. So this is representing this curve is representing, and suppose this part is 1 upon root 2. So you are representing this signal. Okay, and you have some DC signal of 4 ampere. These both are added. So if both are added also, the average value of this positive negative it's 0, and you are getting the average value of this only. So average current will be 4 ampere. What about the RMS current? I told you IRMS will be root under 4 square plus 1 by root 2, that is the magnitude, and this, because of this sign, another 1 by root 2 will come, overall square. This will become 16 plus 1 by 4. So how much you are getting? 65 by 4. So root under 65 by 2, your IRMS. This part is clear, Prasanna?
Yes.
Or you are facing any doubt? Vaishnavi, is this clear?
Yes, sir.
Okay. So this was the concept of AC circuit. Okay. So, means get the result, means root under 65 by 2, what you will get? Tell me the value. This will do the root under 65. What value?
4.03.
4.03.
Yeah.
That is the correct answer only. 4.03. So your IRMS current will be 4.03. Okay. Now if anyone will ask you about the power factor of this circuit, see, If anyone will ask you what will be the power factor of this circuit, then what you will say? Guys, if anyone will ask you what will the power factor of this, then what you will say?
Cos, cos theta.
Cos theta is the power factor, but what value will come? That's what I am asking. See, what was the formula of a power factor? Means this particular is what? This particular is RL load, right? This circuit is your RL load. So, in a RL load, what is happening? What is happening in RL load? This is your RL load, and you have some positive. So in a RL load, it's your V. What it's happening? You are getting the terms in P plus JQ. So suppose you have a P as here with reference, and Q will be 90 degree. So if you want to draw the vector, you have to shift. This is your Q. This is your S. Okay, and this is your P, and this will represent your theta. So cos theta will be base by hypotenuse. So P by S. P by S. Or cos theta is also, you can write R by Z. Okay. But particularly in this problem, you will use this formula. Cos theta is equals to P by S. P is what? P is IRMS square into R divided by S is what? VRMS into IRMS. How so? Because your real power we discussed in this first class only. Real power or average power of RL circuit or any complex circuit, what you are getting? VRMS into IRMS into cos theta, which will be equal to IRMS square into R. So power factor will be how much? IRMS square into R divided by VRMS into IRMS. Okay guys, you understood how this came? Real power was VRMS into IRMS cos theta, and it will be equal to IRMS square into R. So what will the power factor? IRMS square into R divided by VRMS into IRMS. So what is the overall voltage? Voltage is nothing but it's have a DC value also and AC value also. So you can write 4 plus sine t. And what is the current? Current you got. Current value, how much we got the current value? Right, tell me the equations. 4 plus 1 by root 2 sine t minus 45 degree. Correct? We got like this. So if you find the overall VRMS value of this particular VRMS, if you find the VRMS of this, what you will get? VRMS root under 4 square plus 1 by root 2 whole square. Tell me the value. 16 plus 1 by 2. How much we will get? 16 plus 1 by 2. 4.06. 4.06201. This is your VRMS. What about, this is your VRMS, and what about your IRMS? IRMS is, we got the IRMS value 4.03, I think, right? So IRMS value means, solve again, 16 plus 1 by root 2 into 1 by root 2 the whole square. What value it was coming, Prasanna? 4.03, right now?
Yeah, 4.031. Yeah.
Okay. Now substitute the value and get the result. 4.03 the whole square into R value is 1 into RMS, overall VRMS value is 4.06 into 4.03. That will give you cos theta. So solve it and tell me the result. 4.03 square divided by 4.06 into 4.03. How much you are getting? 0.999 something. Lagging or leading? Lagging will come.
Lagging.
Yeah, great. Lagging will come. What will be the theta value? Cos inverse 0.99. So theta value will be
7.11 degrees.
7.11 degree only. So how you will represent now? Means your voltage and current will lag by how much angle? 7.11. Got this one? What we did it? Understood, everyone? See, it's a very simple, it's not tough, because in these questions we know how to calculate VRMS and IRMS. We already discussed in RL network, RC network, anywhere. If you want to calculate the P real power is nothing but VRMS into IRMS into cos theta. That will be equal to your IRMS, average current square, into R. And if you want to find your cos theta value, if you want to find the cos theta value, so cos theta will be what? IRMS square into R divided by VRMS into IRMS. So we need to find the overall VRMS and we need to find the overall IRMS. Put the result and get the cos theta value. And this is RL network, so it is known in a RL network, your current will lag and voltage will lead. So we always talk about the current with respect to current, either current is leading or lagging. So that's why we said that our current is lagging by how much degree? 7.11 degree. Prasanna, it's clear? Vaishnavi, it's clear?
Yeah.
Or guys, means if you are facing any problem, you can ask.
Clear, sir.
Priyanka, for you it's clear?
Yes, sir.
Okay. So, okay, means the things means one thing is left. I will tell you. Suppose Now we'll talk about the complex power, the last topic of the AC network. Complex. Means we are discussing about RL load. Okay. So if we have a V phasor at an angle V at an angle alpha, and we have a I phasor, that is I at an angle beta. If you want to draw this particular diagram, this is your reference. Okay. And this is your reference. So where will be the V phasor? V will be at an angle alpha. And where will be the I phasor? I will be particularly at an angle beta. So voltage will lead current by how much angle? Alpha minus beta. So current is lagging by what angle? Alpha minus beta. Okay, alpha minus beta. Current is lagging by alpha minus beta. Understood, guys? So if you want to calculate your S will be V into I. So if you'll take the angle, V at an angle alpha into I at an angle beta, so what the results you are getting? V at an angle alpha into I at an angle beta, V into I at an angle alpha plus beta. That is wrong. You always remember, if you are writing your S, so you have to write the angle between beta and I, V and I. Okay, you have to write angle between V and I. So V and I means your with respect to current, either current is lagging or leading. So that's why here the angle between V and I is alpha minus beta. So how it can become? If we'll write V at an angle alpha into I conjugate, then it will become minus beta. Then we are getting V into I at an angle alpha minus beta. So we are getting the correct result, V into I at an angle alpha minus beta. That's why we are doing the conjugate. Okay, if I conjugate, it's coming, so that's why we are doing, and it's giving a minus beta. So why conjugate is come to overcome the complex means whatever the complications we are getting. Okay, if we'll do S is equals to V into I, and if we'll simply substitute, we'll get alpha plus beta. That is wrong. Okay, because in the circuit, in a network, you have a reference point, and from this reference point you are getting V at an angle alpha, and you are getting I at an angle beta. What is the angle between this V and I? This is alpha minus beta. So this should come. But if you'll write directly V into I, your alpha plus beta is coming. This is the wrong result. So for getting this result, alpha minus beta, we are putting the conjugate sign. Because our original angle is alpha minus beta. So that's why we have to take the conjugate. Okay. Understood this point, guys? Prasanna understood this thing? Why we are doing the conjugate?
Yeah.
So suppose means whenever you are getting V, mod V at an angle theta V, and I, mod I at an angle theta I, So what will be the overall S? Mod V at an angle theta b into mod I at an angle, you have to take minus theta I. So S will be mod V mod I at an angle theta v minus theta I. So if you will solve this, V into I, 1 at an angle phi can be represented as a cos phi plus j sin phi. So this will be cos theta v minus theta I plus j sin theta v minus theta I. So you are getting Vi cos theta v minus theta I plus j Vi sin theta v minus theta I. So this cos theta v minus theta I is your phase angle, means lagging or leading angle. Okay, that's why I told you na, this is your real power. Real power was what? Vi cos theta. Theta is what? The angle between V and I. Means particularly in a RL load, your V is leading and I is lagging by some angle. Okay, and if this is a reference point, so if from the reference it is an angle alpha and from reference I is beta, then the angle between V and I is what? Alpha minus beta. So that's why we are doing the minus. So we are getting the angle between V and I. So Vi cos theta v minus theta I, and this is your reactive power. I hope you guys got this concept. Guys, understood? Anyone having any doubt, any single doubt, they can ask. If anyone facing any single doubt. If you don't have a doubt, then solve this question. See, you have V of t 60 cos omega t minus 10 degree. That is your voltage. And current is given, I of t current is given 1.5 cos omega t plus 50 degree ampere. Find complex power, apparent power, complex power, apparent power, and real power, and reactive power. So you need to find the complex power, apparent power, real power, and reactive power. You have a 5 minutes, just solve this question and tell me the answer. Anyone got the answer? Guys, what will be the VRMS? Prasanna, what will the VRMS? Vaishnavi, what will the VRMS? (60/√2) at an angle minus 10 degree. What will the IRMS? 1.5/√2 at an angle 50 degree. So what, this is your reference. If you are drawing your VRMS is 10 degree down, and this is your reference. If you are drawing the IRMS, so IRMS is 50 degree up leading. This is your IRMS. What is the angle between this VRMS and IRMS? Overall angle is coming 60 degree. So IRMS is leading by VRMS by 60 degree. So if you will do with the same constant VRMS into IRMS conjugate, you will get the result 60/√2 at an angle 1.5/√2 at an angle VRMS was minus 10 degree and IRMS was conjugate will come. So conjugate, it will become minus 50. So what you are getting? 15 into 6, 90. 90/2, that is 45 at an angle minus 60 degree. If you solve this, what you will get? 45 cos minus 60 plus j 45 sin minus 60. Tell me the result. Cos 60 value is? Cos 60 is how much?
0.58.
Okay. So, and put the value and get the result then. So if you will put the value, you will get 45/2. 45/2 is 22.5. 22.5. And this will come minus, because sin minus 60 degree will be minus j 45√3/2. So this is 38.97. So 22.5 minus j 38.97. This is your S value. So your complex power is what? Your complex power is this only, and apparent power your real power will be what? Real power will be 22.5, and your reactive power will be what? Reactive power 38.97. So this is your complex power, and if you take the mod, you will get 45 only. Okay. What is the difference between real power and apparent power? See, total power is known as apparent power. Okay, means the mod value of a complex power is your apparent power only. Okay, so you have S is equals to you have S is equals to A plus JB. So root under A square plus B square is your apparent power mod value, and complex power we represent in the form like this, A plus JB. And this A what you are getting, it's your real power or active power. Real power, active power, both are same. And this whatever you are getting in terms of J, it is your reactive power. Reactive power. So can anyone tell me this in this what we are getting, lagging power factor or leading power factor? If I am directly asking lagging or leading, then what you will say? This is a lagging or leading? Anyone? Vaishnavi, it is a lagging or leading? If I am directly asking it is a lagging or leading, then what you will say? And one thing also, means this real power, unit of the real power will be watt, and reactive power, unit of reactive power we are writing in VAR, volt ampere rating. Okay, voltage ampere, VAR resistance. So this is actually basically your leading power. Why so leading load? Because your current is leading. Current is leading by how much degree? 60 degree. Prasanna, have you understood this concept? Or Vaishnavi, Prasanna, Priyanka, have you guys understood this? Guys, I'm asking, have you understood?
Clear, sir.
Okay. So this was the story of your AC circuit. So it's completed. AC circuit is completed. Now we will start from the theorems. Before theorems, we need to discuss something. So your AC circuit is done. Now we are moving to fourth chapter. That is theorems. It's a very easy chapter in that you need to study the Norton theorem, superposition theorem, Norton's theorem, superposition theorem. Yeah. And there is also 2-3 things. Thevenin's theorem is there also. Thevenin's. I'm not going to teach you this today. So means I will discuss the questions of previous things. Okay. So these 3 things are come in a theorem only. Norton, superposition and Thevenin's. It will not take that much time. And there is and Milliman's theorem. You will study one topic, Milliman's theorem. Okay, Milliman's theorem is there, and one more topic I think, and another is the Telegan theorem. Telegan theorem. So you have to study in a theorem, Norton theorem, superposition theorem, Thevenin's theorem, Milliman's theorem, and Telegan theorems. So these are a very easy topic, and here also you will study the maximum power transfer theorem. Maximum power transfer theorem. So maximum power transfer theorem you will study, how the power, maximum power can get transferred from the circuit. Okay. Yeah, this means like it will take hardly 3 classes, 3 classes it will take. So almost we had completed the means like suppose we had completed 65% of the network. So 35% is remaining only. Now just open your PDF, the questions bank PDFs what I had sent to you. Up to what questions we had solved? Prasanna, up to what questions we had solved? We solved the question number 16, right? Yesterday?
Yeah.
Okay. So now open the question number 17. In this question number 17, what it's given? Question number 17. This is your question number 17. Means in the circuit shown above, the voltage across the 2 ohm resistor is 20 ohm. Means you have a network like this, okay? And I am drawing in a very, see, you have a resistor, you have a resistor, you have a resistor, you have a resistor, and you have a resistor here. This particular resistor here, and you have a resistor here, and it's given positive negative E. It is given. This is your R1, this particular is your R2, this is your 2 ohm, this is 1 ohm, this particular is 3 ohm, this is 5 ohm, and this is 5 ohm. So in the circuit shown above, the voltage across 2 ohm resistor, you have to find the voltage across this V. Okay, resistor, it's given, it is given 20 volt. Voltage across this 2 ohm resistor, it's given 20 ohm. The 5 ohm resistor connected between the terminal A and B. So this was the terminal A and B, so 5 ohm resistor, it was connected. Okay, the 5 ohm resistor connected between terminal A and B can be replaced by an ideal. So how can you replace this? How can you replace this thing? Anyone? Vaishnavi? So the option is, you are seeing the option, your means option A is voltage across 25 volt with a terminal upwards, voltage across the 25 volt terminal downwards, and current of a 2 ampere upwards and current source of a 2 ampere downwards. So what will be the answer according to you guys? See, it's a very simple and it does not require that much time. You have a 20 volt, this is your 2 ohm, this particular positive negative is 20 volts, so that means what current is coming? 20 divided by 2, 10 ampere current is coming. That means 10 ampere current is flowing like this. If 10 ampere current flowing like this, it's going like this, it's going like this, and it's again merging like this. This is 10 ampere only, right? So if you solve this network, means 5 so 5 this is parallel, so it will become 25 by 10, that is 2.5. so you are getting 2.5 and 10 ampere current. So what is the potential you are getting here? 25 volt potential you are getting. Means this is positive negative 25 volt, this is positive negative 25 volt. So what will be the answer? Voltage source of 25 volt with plus terminal upward. So option A will be the correct for this question. Vaishnavi, understood? How? See, this is 10 ampere is coming because we having a 20 volt. If you will divide by 2 ampere, 2 ohm, you will get the 10 ampere. If it will split it into two parts, again it will join in this junction, you will get the 10, and you have the resistor parallel, so parallelly resistor, the equivalent resistor will be 2.5, and this the 2.5 ohm, the current will move in this 2.5 ohm multiplied with this, you will get 25 volt. That means That means this 5 ohm is consuming 25 volt, and this 5 ohm is consuming 25 volt. If you will divide, if you want to get the current of this 25, this branch current, so 25 divided by 5 will give you 5 ampere, 25 divided by 5 will give you 5 ampere. So overall current you are getting a 10 ampere. So this is the story of question number 17. Now move to the question number 18. So you have a question number 18 like this. This particular is your 4 ohm. This it is given a positive negative 3 volt. This is 0.25 ampere. So the current flowing through the voltage source, what they are asking, how much current will flow from this particular source, this voltage source. So guys, it's very easy. How you will solve this question? So see, you have a 3 volt, that means this is also a 3 volt. This particular branch is 3 volt. 3 volt. How so? Because it is parallel. So what the current you will get? 3 divided by 4. 3 divided by 4 current you are getting, and from here what is the current? It's given 0.25. So what will the overall current? 3 by 4 plus 0.25. So 3 by 4 is 0.75 plus 0.25. You will get 1 ampere. So current will be 1 ampere. So what will the option? Option A is correct for this question. Option A will be the correct option for this question. So question 18, we did it. Now the story of question number 19. Question number 19. So 12 1 ohm resistor are used as a edge to form a cube. 12 cube is what? Cube is like this. I hope you remember the first class. Guys, I hope you remember the first class. 12 and this is 1, 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 this is 1. The resistance between two diagonal opposite, the resistance between the two diagonally opposite corners. So diagonally opposite corner means this is your diagonally opposite corner. So what will be the current, what will be the overall resistance? If you see from this, you remember or forget this concept? Prasanna is not here. Vaishnavi, you remember or forget? I taught you these things. So for diagonally opposite means, for a diagonally opposite, R equivalent is nothing but 5 by 6R. If it was like this, if the connection was like this, then for this connection, it was 7 by 12, and if the connection was like this, between this, then it will be 3 by 4. So just go through the previous topic. Means you have a box like this. If you are solving between the diagonal, you will get R will be 5 by 6 into R equivalent into R present in this. Means this is A, this is I'm writing D, this is B, this is C. So if you are finding the resistance across RAD, it will be 5 by 6 into R. If you are finding the resistance across RAC, then it will be 7 by 12 into R. And if you are finding the resistance between RAB, this particular branch and this branch, then it will be 3 by 4. Okay, so how you will remember? Means like a 4 3 are 12, so 12, 3 plus 4 7, so 7. Okay, just remember this one, this AB. So 3 by 4 we are writing, so 3 plus 4 is 7 and 4 3 are 12, so 12 it's coming. Okay, and how you will remember the diagonal element? How you can remember? 12 minus 7 is 5, 12 minus 7 is 5, and 12 divided by 2, it will come 6. So remember, this means we had already discussed these things, so I am not going to tell you again and again the same concept, because we already discussed in the previous classes. So what will the answer of this? This was a GATE 2003 question. 5 by 6 ohm. Now guys, you have another circuit. Consider the following circuit. Means you have a network. This is your 3 ohm. This particular is R1. This particular is 10 ohm. And this is your I2, this is your N2. It's given, means something given like this. And in the above circuit, the current I2 is given. This particular current, it is given. This particular current I2 is given, that is 2 ampere. And the value of R1 is also given, that is 20 ohm. What will the value of I2 when R1 is changed to 10 ohm? So see, I2 value is given as a 2 ampere, and R1 value it is given as 20 ohm. Now what they are asking, if this will become 10 ohm, then what will the value of a current? Nu I. So if the value will change, guys, if you will change the value of this, the value will change. What you guys are thinking? This value will get changed. If we will change this resistance, the value will get changed or not? If R1 is 10, so the value will never change, value will remain same. If you will change the value of a resistance, your current value is not going to change. Okay, current value is not going to change, current will be the same only. Okay, if you want to check it, check in this particular network. This is 10 volt, this is 2 ohm, this particular is 2 ohm, this particular is 4 ohm. So if you will change, if you will divide this resistance, means this particular resistor by 1 ohm, and earlier you were getting the current some I1. So just check it, the value is getting double, triple, and what is happening. Okay, let's we are checking. Okay, I don't know it whether it will get changed. Suppose we don't know. So suppose the value was earlier it was 2 ohm. So first find the value. 10 minus x divided by 2 plus x by 4 plus x by 2. So we are getting 5 is equals to minus x by 4. So x value we are getting minus 20. Okay, minus 20. Minus 20 divided by 2. Minus 20 divided by 2. Minus 10 ampere it is coming. Now suppose I change the value, it is as a 1 ohm. This is as a 4 ohm only. This is 2 ohm only. So what's happening? The value is getting changed. This is your x. So 10 minus x divided by 1 plus 10 by 4, that is x by 4 plus x by 2 is equals to 0. So this will be 3x by 4. So 10 is equals to minus 3x by 4 minus x plus x. So what you will get? Minus x by 4. So x value you are getting minus 40. Minus 40. So minus 40. Yeah, minus 40 divided by 2. So we are getting 20 minus 20 ampere. So see, the values are getting changed. Means if we are doing the things, the value is getting changed. Means like if we are dividing the register, the values are here. We are seeing that the values are getting changed. Okay. Let's means you just try this part by yourself. Means this is your homework. Means, and we'll discuss tomorrow these things. Okay. Suppose this is your 2 ohm resistor. This particular branch is your 4 ohm resistor. This is your, suppose I am taking 4 ohm resistor, and this is your battery, it is 10 volt battery. Okay, now what I am saying, this is your 2 ohm, this is your 4 ohm, this is your 4 ohm. This is your first circuit. Now in a second circuit, what I am saying, what you are doing, this you are decreasing the value of this particular resistor by half, and your voltage is remain same, and this resistor is remain same, and this resistor is remain same. Now you have to calculate the I1 value in this circuit and I1 value in this circuit, and just check it, this I1, whether this I1 is coming as a I1, or suppose you take I2, whether this I1 is coming equal to I2 or it's getting changed. Just do as this as a homework, then you will able to understand this problem, and we'll discuss tomorrow again these things. So here something is given like this. Here you have I of t. Your T network is given, and it's given like this. This is 2 ampere. This is 2 second, and the voltage waveform we are getting like this. 2 volt, and this is 2 second. This is v of t. So and in the option they had mentioned whether it will be a capacitor, whether it will be a inductor, whether it will be a resistor. So we know that v of t is equals to L di by dt, and I of t is equals to C dv of dt. Okay guys, what will be the differentiation of a square? Differentiation of a square will give you triangular pulse. Okay, so this is getting differentiated, so that you are getting a triangular pulse like this. So if this is getting differentiated and you are getting the triangular pulse like this, that means this particular is representing a capacitor. Okay, and what will the value of this capacitor? Capacitor or inductor means, because see, or if you will differentiate, let me tell you, means I'm sorry, differentiation of this, yeah, if you will differentiate this function, I'm really sorry, means you have v of t is equals to L di by dt, and you have I of t is equals to C dv by dt. So differentiation of a triangular pulse will give you straight line. Means if you will differentiate, see, triangular pulse means it's having a some slope, suppose slope is 1, and if you will differentiate dt, you will get a constant value. So this constant value is coming. So what is the slope of this? So I of t is nothing but y2 minus y1. So y2 is 2 minus 0 divided by x2 minus x1, that is 2 second. So you are getting slope as a 1. Okay, slope as a 1 means you are getting di by dt value. Di by dt value is 1. This di by dt value is coming as a 1. Okay, how so? Means I just find the slope of this particular graph. So y2 minus y1 divided by t2 minus t1. So y2 minus y1 divided by t2 minus t1. So you will get the slope as 1. So slope you are getting 1. This as a 1. And what is the voltage you are getting? Up to 2 second. Up to 2 second you are getting the voltage 2 volt. So 2 L 1, you are getting L value as a 2 Henry. So what will be the option of this answer? So option B will be the correct. Option B is inductor 2 Henry. Okay, and the integrations of this, you will get the triangle. Okay, differentiation of a triangle, you will get differentiation. If you will differentiate the triangle, you will get the square pulse. If you will integrate the square pulse, you will get the triangle. Okay, so with the help of this also we can find the value of an inductor while integrating this, taking the value like L 1 upon L. Okay, taking the value v of t into dt into I. This is in the form of integration. By this also you will get the value. Okay, so this was the story of a question number 21. So remaining question number 22, 23 we'll do it soon. Okay, so tomorrow we'll start the next chapter, that is theorem. So theorem chapter is going to start tomorrow. Okay guys,